So, problem number 17 is which of the following cannot be obtained using a phase diagram? Melting temperatures of various phases, that is always obtained, right? It cannot be, it says it cannot be. Okay, so we get actually melting temperature of various phases. Then temperature range for solidification, this also we get. Equilibrium solid solubility, that also we get. Purity of material we don't get. Okay, so the correct option is D here, because a phase diagram gives all information regarding the melting temperatures of various phases all types of temperature ranges for solidification. It also gives the equilibrium and the equilibrium solubility. But cannot give information about the purity of materials. Next we move to problem number 18. It says the maximum number of phases that can be simultaneously in equilibrium for a one component system, that is 3, right? The answer is C is the correct option. C is the correct option. Because at triple point we get the maximum number of phases in equilibrium. Okay, triple point. Next we move to problem number 19. It says by the graph which statement is correct? Melting point increases with pressure. So melting point means what? Melting point means solid liquid coexistence lines we need to see. Now it says is incorrect. Okay, so melting point increases with pressure. So if we increase pressure here, so suppose we first consider this pressure here. So this is the corresponding melting temperature, right? If we say this is MP1 at pressure P1, and if we consider this one, this is pressure P2, and the melting point at pressure P2 is MP2. This is MP2. So P2 is greater than P1 because pressure increases in this direction, but MP2 is less than MP1, right? So this is the incorrect statement here. Let's see the other one. Melting point decreases with pressure. This is correct option. Boiling point increases with pressure. Now see the boiling point. Okay, suppose this is the melting point and this is the normal boiling point here, right? So we say this is your boiling point BP1 at pressure P1, and boiling point at pressure P2 is BP2 here. This is BP2. So P2 greater than P1. So this one is correct. This is incorrect. P2 greater than P1 and BP2 is greater than BP1. So boiling point increases with pressure. This is also correct statement. Solid, liquid and gas can coexist at the same temperature and pressure. This is also correct, right? So this point, at this point, triple point at T3, this is T3, point T3. This is the triple point T3. Okay, so at triple point temperature T3 here, so this triple point, this is triple point. So at triple point, all these three phases, they can coexist. So this is also correct statement. This is triple point. So option A is the correct option here. Next we move to problem number 20. It says consider the phase diagram of carbon dioxide at equilibrium. The incorrect statement is at 200 K temperature, on increasing the pressure from 1 to 50 atmosphere, the gas condenses to liquid. So 200 K temperature is somewhere here, because this pressure is given atmosphere, temperature is Kelvin. So 200 is somewhere here. So if we increase pressure from 1 to 50, so pressure 1 is here somewhere and pressure 50 is here somewhere. The gas condenses to liquid. This is incorrect, right? Because gas condenses to solid here. Okay, so gas condenses to solid here, not liquid. It is not possible to obtain liquid carbon dioxide from the gaseous state below 5.11 atmosphere. That also I mentioned while discussing the phase diagram of carbon dioxide. So below 511 pressure, atmospheric pressure. So here somewhere, suppose 1 atmospheric pressure. So if we start with solid phase here somewhere, we get directly, if we increase the temperature here, we get gas phase, right? So we don't get liquid phase below 511, because below 511 the liquid region ends here at 5.11 atmospheric pressure, right? So below 5.11 it is not possible to get liquid carbon dioxide from gaseous state. So this is also correct. This is the correct statement. Both liquid and gas coexist at 298.15 Kelvin temperature and 67 atmosphere. So this is 67 atmosphere, this is 298.15 Kelvin, and this line corresponds to liquid vapor. So this is liquid vapor coexistence line. So you see, so at 298.15 Kelvin temperature and 67 atmosphere pressure, liquid and gas can coexist, this point, right? This is also correct. This is also correct statement. And the last option is, with increasing pressure, the melting point of the solid increases. So you see, this is solid liquid coexistence line. So melting point, in order to obtain the information about the melting point, we need to consider this solid liquid coexistence line. So this line we need to consider here, right? And we get the positive slope, right? So dp/dt is positive here. So it says that with increasing pressure, the melting temperature will increase. That's what. So this is also correct. With increasing pressure, the melting point of the solid increases. This is also a correct statement. So option A is the correct option. Correct option. A is the correct option. We move to problem number 21. It says the vapor of a pure substance when cooled under a pressure less than its triple point liquefies first and then solidifies directly, remains unchanged. Right? So we just discussed in this problem. So if we cool under a pressure less than its triple point, so we consider vapor phase here. So this is the vapor phase, this is the triple point. So a pressure below triple point, if we cool it, okay, so we go, if we cool it like this side, so we get gas to solid directly, right, without going through liquid phase. So C is the correct option. So C is the correct option. Problem number 22 says, draw a temperature composition phase diagram for a binary system having a single eutectic, a single peritectic. Peritectic means here corresponding to the incongruent melting compound and no solid solution. Okay. So we are considering here A and B, substances A and B, forms compound AB. So if we draw temperature composition diagram here, we consider a particular pressure here, P is fixed here. So here temperature that, and then composition. Okay, composition means percentage of B. Okay. So here percentage of B 0, from 0 to 100 we go. Okay. So here we get pure A. Okay. So here we get 100% A, and percentage of B increases in this direction. So here we get 100% B. Right. Now we draw it, we get like this. This is liquid plus A we get. This is the liquid phase. This is liquid plus AB. So this is A plus AB, right? And here you get AB plus B, and we get here like this. Okay, this is L plus B, liquid plus B. So here you get liquid plus B in this region. L stands for liquid, liquid solution. Okay, so here you get liquid solution, here you get liquid solution, here liquid solution plus A, liquid solution plus AB, and A plus AB, and AB plus B. So this is the phase diagram. Identify the phases present in the figure and give the formula of the compound formed. Okay, so an incongruent melting compound is formed here. Is formed here. It is formed at 25%, roughly 25% of B in A. So the formula is so this is forming here somewhere for this concentration of B. So concentration of B is 25% here, so concentration of A is 75%. The formula is A3B. Okay. Now region 1. So what are the region? Region 1 here. This one region corresponds to solid A. 2 corresponds to solid A plus we have the compound, right? Compound A3B. So solid A3B. Compound 4, region 4 is solid B plus solid A3B, and region 5 is solid B and liquid. Problem number 24 is identify the phases present in the figure. It shows two substances, right? Two substances are completely immiscible in the solid phase. There are 4 two phase areas and one phase area. So this is one phase area, and these are all two phase area here. Okay. At region 1, the two phases in equilibrium are solid A and liquid. At region 2, solid B and liquid are in equilibrium. Right. Regions 3 and 4 solid A and solid B with one of the materials undergoing a phase transition to second solid. And then if you see here, so concentration of B increases here. So this region 1 is the two phases in equilibrium are like here. If we consider A and B are there, so the solid A and liquid B and liquid are in equilibrium, and region 2 solid B and liquid, and region 3 and 4. So you have the solid A and solid B with one of the materials undergoing a phase transition to second solid. Next, move to problem number 25. Identify the phases present in the figure. So here you get liquid at the top, and then there are two phases here, and then you have the solid solution here. Okay. So it shows shows the complete miscibility of the materials in the solid phase. Because you see solid solution region here, okay. So these are there are two one phase areas. This is quite obvious, liquid region and the solid solution region, right, and one two phase region or two phase area, one two phase area. So these are the region, liquid region and solid solution. These are the regions. These are one phase region, and this is the two phase region here. Okay, this results from the ability of the substance to substitute freely for the others, in the crystal lattice, because of the similarity in the size of the molecules, right. Atoms or ions, charge, etc. Okay, so actually this is due to the ability of substance to substitute freely for the other in the crystal lattice because of the similarity in the size of molecules, charge, etc. Next we move to problem number 26. It says, with reference to a two component system, a vapor line indicates a region where the temperature and pressure remains stable, a region where the solubility remains stable or remains constant, an area below which components do not mingle, an area above which both the components mingle to form a single mixture. Here option A is correct option. So A is the correct option. Okay. A vapor line is another name of the isotherm, name for isotherm. It represents constant temperature and constant pressure relation at which the equilibrium is obtained. It helps us in finding out the equilibrium condition. Next is problem number 27, which says, which of the following statements is not true for a system that has reached the eutectic temperature. The system is an open system, the system is miscible fluid, components lie in the liquid state, a region between sublimation and eutectic curve lies stable. Again, A is the correct option. This is not true actually. The eutectic temperature is achieved by melting in the point where the density of liquid state is equal to the density of the vapor state. Hence, the interference between the liquid and vapor vanishes, resulting in a miscible liquid. This can only occur in a closed system, right? In a closed system. Otherwise, the vapor will escape. So, this is the incorrect statement. The system is an open system is an incorrect statement here. Now, number 28. Which of the following statements are correct about the equilibrium point on a two component system? All the compounds are liquid. The boiling point of the mixture is less than the boiling points of the individual compound. The degree of freedom is 0. Invariant reaction takes place. So, here in most of the cases B is correct option, because the eutectic point on a phase diagram is a point at which the mixture boils at a temperature lower than that of the pure substance. The substance attains equilibrium state. Next, we move to problem number 29. It says in vapor liquid equilibrium, the more volatile components tends to accumulate in the, very simple this one. So, in vapor liquid equilibrium, the more volatile component tends to accumulate in the vapor phase. So, A is the correct option. More volatile the liquid, more it will escape to the vapor phase. So, A is the correct option. Problem number 30 says following is wrong about a phase diagram. Which one is wrong? Gives information on transformation rates. The relative amount of different phases can be found under the given equilibrium condition. So we have to find the incorrect statement rather here, right? So this is correct option B, because it says the relative amount of different phases can be found under the given equilibrium condition. This is correct statement. It indicates the temperature at which different phases starts to melt. This is also a correct statement. We can get the information from the phase diagram. Solid solubility limits are depicted by it. It is also correct statement, right? So the only incorrect statement is this one. Okay, so this is the incorrect statement, because it does not give the information on transformation rates. It does not talk about the rate. Incorrect statement this one is. So option A is the incorrect statement. So A is the correct option.